Hello, welcome to this lecture. My name is Miracle Chibuza Marcel, and I'm the founder and the director of the Pan-African Citizen Science Laboratory. So today we are going to be studying the International Space Station. The International Space Station. So before I do that, I need to do some recap on our last lecture. In our last lecture, we studied the first space station, and I said the first space station is the Soyuz 1, which was built by the Soviet Union. Okay. Then after that, we have the Skylab, which was built by the Americans. Okay. And then we have the Mir, which is the Skylab was the second. Then we have the Mir, which is the third space station built by the Soviet Union. But right after that, the Soviet Union collapsed. Okay. And then the whole thing, the whole mission was transferred to the Russian Federation. And I said that the Russian Federation collaborated with the West. Okay, so both the Russian space travelers, cosmonauts, and the American astronaut, European astronaut, okay, made use of the Mir space station, and that collaboration led to the construction or the assembly of the International Space Station. So understand where everything is coming from. So the International Space Station is basically the fourth space station, and a lot of people do not know this. So there have been other space stations before the International Space Station. So today we are going to be talking about the International Space Station. So, so the table of content of my teaching today, we focus on the introduction of the ISS. I'll talk about ISS identity and configuration. I'll talk about ISS module. Then I'll talk about some important information about the ISS. I'll talk about ISS internal environment systems. I'll talk about ISS power systems. I'll talk about the scientific studies or experiments done on the ISS. Then I'll talk about ISS interior, and then I'll talk about the ISS retirement of future space stations. So these are the areas of concentration of today's lecture. So by the way, this lecture is sponsored by the Free Astro Science Group. So the International Space Station. What is the International Space Station? The International Space Station, or ISS, is a massive, habitable, modular orbital complex that transits Earth at low Earth orbit. I said the ISS, as you can see it there, you can see the background, is a massive, habitable, modular orbital complex that transits Earth at low Earth orbit. So I have made 3 points here. I said it is massive, it is habitable, that means human beings can live in it, and it is modular. Okay, I will explain what I mean by module in my next slides. So that is it about the ISS. So it is moving at low Earth orbit, just like other satellites. So the ISS is a joint project of NASA, which is the space agency for America, United States, Rosmos, which is the space agency for Russia, JAXA, space agency for Japan. Then we have European Space Agency, which is a space agency for some select European countries, and then the Canada Space Agency. So you can see their flags. There are 15 countries that combine their resources to support and sponsor the International Space Station. Now, that doesn't mean that other countries cannot use it. Like countries like these wealthy countries like Saudi Arabia, United Arab Emirates, they've all sent astronauts to the ISS. Okay, even countries like South Africa, South African astronauts have gone to the ISS. So we have a good number of countries that have sent astronauts there. So they're just for collaboration purpose. The collaboration does not extend to sponsoring it. Okay, these countries put their resources together to sponsor the ISS in terms of its construction and now its maintenance. So there are 15 countries there. So now let me talk about ISS identity and configuration. The assembly or the construction of the ISS started way back in 1998 and it continued till 2011. So do the math, 1998 to 2011, I think it's about 13 years. About 13 years. Okay. So why am I talking about this? Why is it important to emphasize on that? Remember the first and the second space station, which are the Salyut 1 and Skylab, they were a single component, a single module that we have built here on Earth and sent to space. Okay, they were built here on Earth and sent to space. And then the Mir, just like the ISS, was also uh, it has different modules. So those modules were separately sent to space. But what makes the ISS different is that it took these 13 years to be completed. However, we need not to complete it before sending astronauts there. Okay, we need not to complete it 100%. It's not like a building where you have to complete it before you can enter it. Okay, it's different from normal buildings. So just 2 years after the first launch, the first module was launched. Just 2 years in 2000, the first crew arrives. Okay, and since then till today, it has been continuously inhabited by astronauts. Again, the reason why I'm emphasizing on this is because for Salyut 1, it spent a total of about six months in space orbiting Earth, but human beings spent 23 days aboard it. Okay, human beings spent 23 days aboard it. So compare the two, 6 months, 23 days. Then we have the Skylab. Okay, it spent 6 years in orbit, but human beings occupied it for just 171 days. And the Mir spent about 15 years, but human beings spent like 10 years in it. So you see, so for majority of these space stations' lifespan, human beings were not on it. So, but the ISS is the only space station that have housed human beings since its inception. So in 2011, the ISS was completed. Okay, I mean the modules, the other parts like the solar arrays and so on and so forth. It was fully completed. So when the ISS was fully completed, the attention now shifted to maintenance and upgrade. So that is what I want you to know about this. Now let's talk about the ISS module. So I want you to think of module as boxes, okay? Then you have some some entrances like some corridors where you can enter from one box to the other. So this is the way the ISS was built. So a module is simply a self-contained section of the International Space Station. So each module is launched separately into space. They were built on Earth and they were launched separately in space. And each module is designed to perform a specific function. And then they are connected. They are launched in space and connected. So this is what I mean by module. So when I was defining ISS as a modular complex, orbital complex, so this is what I mean by that. So this is the first first module that was launched in space. I'm going to talk about it in details. So now here is the first. This is sorry, not the first module. This is U.S. Harmony module. This is the U.S. Harmony module. So which is the central hub connecting the US, European, and Japanese labs. So this is the diagram, and here this is the live picture of astronaut in this module. Okay, then we have the US Destiny Laboratory, which is the main US research laboratory on the ISS. So here is the diagram, and this is an astronaut inside the module. And here is the US Tranquility module, or you can call it the No 3. It provides life support systems for the astronauts and also provides a point for attaching the the, the cupola. I don't know if I pronounced it well. The cupola. So the cupola is like the window on the ISS, that popular window on the ISS. I'm going to talk about it in my next slide. So it's on the US Tranquility module. Okay. So this is the ISS cupola. It is known. It is said to be the best human-made space window ever built. So there, it has about 7 windows. Okay, so on it, astronauts can use it to operate the robotic arms on the ISS. ISS has a robotic arm, so I'm going to talk about that. It's a very long arm that helps that helps astronauts to hold on to cargoes, cargo that is coming in, or even help astronauts doing space work. So astronauts can even come over here to relax, look at Earth, take pictures, and also the use for visual document monitoring. Okay, so then we have the European Columbus Laboratory, European Columbus Laboratory, which is European Space Agency's main science lab in orbit. So here's the diagram. Here's a live picture. And then we have the Japan keyboard module. The Japan keyboard module is basically the largest ISS module. So you look at how big it is, different sections. It even has an externally exposed experiment platform, I mean exposed to space. Okay, so that's it. Then we have the Russian Vesda service module. It's an early living quarter and propulsion control for the astronauts. And we have the Russian Zaya module. I've shown you this in the previous picture. It is basically the first module, the first ISS building block ever launched. That was the first. Okay. So now let's talk about Canada's ISS contribution. Like I have just shown you, the United States, the Russians, the European Space Agency, Japan, all have a module on the ISS. So the question is, where does Canada belong? The answer is that Canada does not have its own module, okay? But they contribute to the ISS through this robotic arm. They have this robotic arm called the Canadarm 2. Canadarm 2. Okay, it's a long, like 17.6 robotic meter long robotic arm. So here's the sketch of the Canada arm. It is used to move cargo spacecraft, like you can see it here. Can also used to move astronauts, not to support the astronaut doing space work, and also used to move some components of the station. This Canada arm is essential for doing the ISS construction, doing the construction and the construction phase, and now the maintenance phase. So this is the Canada contribution to the ISS. Now let me talk about some important information about the ISS. So altitude and gravity. Altitude and gravity. The ISS is orbiting Earth at an altitude of between 370 to 460 kilometers above sea level. Okay, so this altitude it varies due to air drag. I'll explain that. I'll explain that in my next slide. Okay, so we know that as you move up, gravity reduces, right? Okay, gravity reduces. So at 400, let us calculate the gravity of Earth on the ISS at that altitude of transit. Okay, so if we just take 400 kilometers to simplify our calculation, and you do the calculation using some physics equations, you discover that the acceleration due to gravity at that height is 8.7 meters per second, which is about 90% as strong. Okay, it was the value on Earth, on the surface of Earth is 9.8, but on the ISS it is 8.7. So that is 90% as strong. So there's still gravity, there's still force of gravity on the ISS. So there's nothing like zero gravity. It is not a zero gravity, it's the wrong terminology. Okay. But why is it that whenever we look at pictures or videos of astronauts on the ISS, they appear to be floating, they appear to be weightless? Okay. Appear to be weightless. And the simple answer is that every falling object is weightless. Every object that is falling here, whether on Earth or in space, is weightless. You can say, oh, but weight is equals to mass times acceleration due to gravity. Okay? Yeah, that is not weight, that is the force of gravity. Weight is like a reaction of the surface you're standing on you. So as the force of gravity is pulling you down, and if you're on a surface, that surface is going to provide the counter force that will push you up. Okay, that will push you up. So providing the action and reaction force. So that is what, if you're on a weighing scale and you want to measure your weight, it measures that reaction, and that reaction is called your weight. So if you are falling, there's no reaction, so there's no weight, but there is force of gravity. Do you understand? So there's force of gravity. So understand that. So the reason why the astronauts are floating is because they are in free fall. So they are weightless, but there's force of gravity on them. So ISS reboost, every now and then ISS is reboosted. Okay, the ISS altitude is not fixed. Remember what I talked about here? I said its altitude varies from 370 to 460 kilometers, and I said the reason for this is because of drag. Okay, at that 400, oh, at that height, there is still air particles here and there, and the ISS is moving very fast, and speed has a relationship with like drag and speed. I think there's some sort of relationship. So the faster an object is moving through a medium, the higher the drag. So that drag reduces the speed of the ISS. So that is why it begins to lose speed and begins to descend. So every few months, the ISS is reboosted. Okay, it is reboosted by the Russian Progress spacecraft and also sometimes visiting cargo. Let me explain what I mean by that.
The space
Oh, let me explain what I mean by
The
that.
space station is constantly falling, but it's moving forward so fast that as it falls, it keeps missing the planet. This continuous fall creates a loop, keeping it circling around Earth rather than crashing into it. But the space station isn't completely out of the atmosphere, which does contain a tiny bit of air. And as it loses speed moving forward, gravity starts to pull it a little closer to Earth each day, meaning it would eventually fall to the ground. To fix this, the station uses small rocket boosts every few weeks to climb back up, which keeps it in perfect orbit.
So that's exactly how it works. That's how the ripples work. So in terms of the size, the ISS is arguably the largest human-made structure in space. The longest side measures about 109 meters end to end. I mean, from here to here. Okay, so and that is roughly the size of an American football field. So this is an American football field. So just roughly the size. So know, if you have seen an American football field, you can imagine the ISS being as big as that field. So it is so big, the largest human-made structure in space. Now, the ISS is inclined at an angle of 51.6 degrees with respect to the equator. So this is the equator, and here is the angle at which it is transiting Earth. Okay, and this angle is chosen to allow uh, cargo missions to the ISS from both the United States, especially from Russia, from Florida, and from Russia. Uh, from Russia is Baikonur. That is where they send uh, rocket to space, especially to the ISS. In terms of speed, the ISS is very fast. It is moving at a speed of about 28,000 kilometers per hour. Like if you want to understand what that means, I'm going to use Mach. Mach represents the speed of it represents the speed of sound in air. If I say Mach 1 is speed of sound, like the same thing with the speed of sound in air. Then we say Mach 2 means that the object is moving at 2 times the speed of sound and air. So now I say 22.7. The ISS is moving at Mach 22.7. That means it is moving at 22.7 times the speed of sound and air. So that's at a normal speed. So it is faster than a normal airplane. In fact, our normal airplane, passenger airplane, is moving at a speed that is below Mach 1. So you see, the ISS is very fast. It is faster than bullets. It is faster than ballistic missiles. It is faster than most human-made objects. Okay, I didn't say it is the fastest object. There are objects, there are spacecraft that are sent to other worlds that are faster than the ISS. Okay, so, but I'm just telling you, it is among the fastest objects you can that is orbiting Earth. Okay, so it is very fast, moving at Mach 22.7. So, but if you look at Earth from the ISS, it appears like it is just moving just normal motion. Remember, the Earth is very big. Earth is very big, so it is not. This is a very fast motion. Okay, so in terms of complete orbit, remember it is moving very fast, so it takes ISS about 90 minutes. That is 1 hour 30 minutes to make one complete orbit around Earth. Just 90 minutes. So within one Earth day, within 24 hours, it can make can make complete 16 orbits. So if you are an astronaut on the ISS, you're going to experience 16 sunrise and 16 sunsets on the ISS. In terms of mass, the ISS is pretty massive. ISS is pretty massive. It weighs around 420,000 kilograms, so which is about the same takeoff mass as a Boeing 747 jet. So look at the Boeing 747 jet. Okay, just the same size. Boeing 747 weighs around 400,000 kilograms. Okay, so if you compare that to 420,000 kilograms, so they're just pretty comparable. Okay, so however, the ISS, the weight of the ISS is zero. Remember what I talked about, but the force of gravity on it is not zero. Okay, the force of gravity on it is not zero. So that is why Earth keeps pulling it down. Earth keeps pulling it down, but it is moving so fast enough that it is missing Earth. So it keeps falling. We call that free fall, free falling body. So in terms of sighting, the ISS is so massive that you can see it from Earth without a telescope, without any aid. Okay, the ISS is basically the third brightest object in the night sky after the moon and the Venus. So here is the ISS there. So the third brightest object in the night sky after Venus and the moon. The moon is the first brightest object in the night sky. And we have Venus, then we have the ISS. So it is pretty bright. So whenever it is transiting, you can see it with your eyes. You can see it move. In fact, a lot of people have seen it, but they can't interpret what they've seen. Before I started uh, sighting the ISS, okay, I started sighting the ISS recently in 2000. I learned how to sight it. But before that, I used to see moving bright objects when I was younger, and I couldn't interpret what I saw. So that's exactly, you probably have seen it, but you didn't know it was ISS. So it is very bright and it moves. Then, in terms of the maximum astronauts the ISS can contain, okay, the largest number of people ever aboard the ISS is 13 astronauts. So the ISS can contain between 1 to 13 astronauts. These are the astronauts. So let's talk about the internal environment systems of the ISS. Internal environment system of the ISS. The atmosphere inside the ISS is around 21% of oxygen and 79% of nitrogen, just exactly like the Earth atmosphere. And the pressure is maintained at 1 atmospheric pressure. So this is just much like Earth. So when you look at astronauts in space, look at astronauts in space, they appear normal. They're not wearing their spacesuit. Now, this is confusing to a lot of people because they they assume that astronauts are always going to be in their spacesuits, going around the space station with their spacesuit. And the answer is that they only are in the spacesuit when they are performing spacewalk or when they are coming from Earth to International Space Station. When they are right there on the space station, they don't need to wear their spacesuit. Okay, they don't need to wear their spacesuit. They're just normal because the environment right inside the ISS is just like Earth. What is lacking is just the gravity, microgravity. Okay. There's also water recycling system, which is about 90% efficient, and there's also uh, the system that removes the carbon dioxide they breathe out. These these chemical scrubbers that removes the carbon dioxide that they breathe out. So in terms of the power system, you can even see the solar arrays there. ISS is powered by 8 massive solar arrays. You can even see that. 1, 2, 3, 4, 5, 6, 7, 8. 8 massive solar arrays. Okay. And can generate up to 120 kilowatts of power. Now, these solar arrays are able to rotate to be able to track the sun. They need to be facing the sun heads on. And then there are batteries of the ISS to store the energy during nighttime. Remember, I talked about 16 sunrise and 16 sunset. So during the sunset, the energy in the battery will be used to power the space station. Now, the scientific studies, which is the most important aspect of the ISS. On ISS, the astronauts or those from the ground station can study the sun. They can study the sun. They can study Earth from the ISS. They can study human body from the ISS, and then can also study the behavior of matter on in microgravity of the ISS. And they can also study plants, microbes. Can generally study everything in the universe, any scientific thing, including the universe and also future space technologies. In fact, more than 4,000, more than 4,000 scientific investigations from over 100 countries have been conducted on the International Space Station, so making it the largest and the most productive laboratory ever built in space. So ISS interior, right inside the ISS, there are so many sections. We have sleeping areas for the astronauts. So this is the astronauts uh, sleeping space. We have scientific laboratories. Okay, we have exercise equipment for the astronauts. We have so many things. We have storage areas. We have solar panels for power. So here is just interior, typical interior of the ISS. Typical interior. It looks so beautiful and very sophisticated. Okay, so now, how about the retirement and the future space station? Now, originally, the ISS was designed to last for just 15 years, to operate for 15 years, but now it has been operating for about 25 years. Okay, so the ISS is expected to retire in 2030, just about, I mean, 2030 to 2031, about 4 to 5 years from now. Okay, it is going to be deorbited and it's going to land in the sea. So and when that happens, private companies might come in, build smaller space stations. Okay, we already have the Chinese space station there, so there is future. However, NASA, those countries that I mentioned, and probably more countries are going to join in. So NASA, uh, they are shifting their focus to building another space station, or that will be orbiting the moon. Okay, they're going to be, so that space station is called the Lunar Gateway. Okay, so it's going to be orbiting the moon, and it is expected to support the Artemis program, the ongoing Artemis program. And the Artemis program, the space station, is going to be used as a staging point for moon landing, deep space missions, and lunar surface research. So that is the end of my lecture. If you have any questions, you can send them to me. Thank you.